Welcome to the fifth Industrial Revolution. My name is Richin Kansal. After spending 20 years in healthcare, I now teach at Seton Hall University and run its Center for Leadership Development. I see at least two trend lines that are happening right now in our world, which tend to be running in parallel, and let's see if they will meet in the future. One of the trend lines is around sustainability. We are seeing a lot of changes to climate. It's pretty evident with the latest news on Lake Powell drying up or wet temperatures rising, and the lack of oxygen, and frankly even the pandemic is an indication of the virus becoming stronger than the immunization systems, and and the earth is becoming less sustainable for human life. So that is one trend line, and we are seeing now a lot of effort in terms of how can we sustain. Number two, the trend line is race for space, right? So everyone is now going into space. As we spoke with one of our guests a few weeks back, the cost of sending a kilo in space has gone down from $56,000 to $2,600, and it is reducing. So we are about to get to a point where innovation in terms of space exploration will be done at scale because the cost would have reduced enough. So that trend line, that train has left the station. Wall Street is calling it the next trillion-dollar industry. And that is another trend that we are seeing. Will they intersect in the future? Don't know. Will lack of sustainability accelerate the race for space? Potentially, probably, we'll see. But one biggest barrier to either sustain life on Earth or to live in space, as far as human bodies are concerned, is our bodies are not adept to those environments. We evolved to live on Earth. We did not evolve to live on Earth that would look different than it was a few million years ago. We did not evolve to live in space, which looks very different from the atmosphere on planet Earth. So is health technology going to really enable wherever these trend lines meet? So that's the question that we're exploring. And how it will change our socioeconomic structures is something to be seen. So in this project, of course, Anthony Pizzoni and Tillman Pitcher, two of my students, are helping me. And today we have the pleasure of having Dr. Jordan Okie from Arizona State University join us to share some of his views on these topics. And I'm going to read here, Professor Okie is an integrative and quantitative biologist. He is working on macroecology, microbial ecology, macroevolution, and metabolic scaling. I saw on your website something about change in size of bodies, and I'm curious to hear about that a little bit later. But Dr. Okie, Jordan, welcome again to the show. Why don't you, introduce yourself and talk to our audience a little bit more about the work that you do?
Okay, yeah. Well, thank you for inviting me, Richin. It's a delight to be here. So, I'm a research professor in the School of Earth and Space Exploration at Arizona State University. So at ASU, we have instead of departments, we have schools. And some who know me, who knew me, 5-10 years ago, may be surprised to hear that I'm in the School of Earth and Space Exploration, because my background is originally in biology and especially in ecology. But it's a good fit because my research aims to understand the big picture evolution of biodiversity and biocomplexity over the course of the history of Earth. Mm-hmm. So going back several billion years. And that includes the evolution of complex cells via the cooperative integration of an endosymbiont within a host cell. And so that was a key step that led to the evolution of cells that we see in all plants and animals that were required for the evolution of larger organisms and more complex organisms. So that step involved this cooperation and this shift in the level of organization from a simple cell, a prokaryotic cell, to a more complex cell that has a former organism or individual residing inside of it, called an endosymbiont, that evolved into organelles called mitochondria, and also chloroplasts. And so this innovation was key to the evolution of biocomplexity on Earth. Another example that I work on is the evolution of complex societies, including human societies, which involves cooperation between individuals to form these complex, larger metabolic structures. So my research is really focused on understanding like large scale and fundamental constraints on the distribution and activities of this biodiversity and this biocomplexity today as well. So in this, by that I mean, for example, that I try and understand why there's such a greater number of species of plants and animals in the tropics, in the warm tropics, than compared to really cold places,
right.
Or really low energy places. So a lot of this then fits with the aim of identifying laws of life, and which then could apply to understanding life elsewhere in the universe, which is a goal of astrobiology. And unifying our understanding in biology and ecology and evolution across all domains of life. So from the simple bacteria to plants and animals, a lot of theory and understanding of the mechanisms operating an organism the biologists have really focused on their specialties. And so I aim to kind of integrate that understanding more. So, and what's really clear is that energetics plays a major role in the evolution and ecology of life. So a lot of my work then focuses on understanding that role of energy, and innovations do as well. So in the course of the Earth history, innovations have played a huge role in allowing organisms to get more complex, larger. They then have different, develop new niches and metabolisms that allow them to transform the planet in different ways, so that to the point that today we have this planet that in which animals and plants and humans can live with plenty of oxygen in the atmosphere. This is all due to these biological innovations. And a key innovation today that's transforming the planet too is the innovation in technologies fueled by agriculture and industrial innovations that have really fueled the transformation of the Earth by humans. So humans now are a key player in the Earth system. And that's why I do try and address to some degree humans in my research, although I'm certainly not a social scientist. So I could, but I'm interested in broadly the topic of human ecology.
This is very interesting. And, you talked about 4 different, and let me, in a layman's language, call them triggers of life on Earth, right? So you talked about the endosymbionts, you talked about energetics, and you talked about biological innovation. And you talked about that you study this from perspective of what has happened over the last billions of years. So if these 3 forces, and we'll come back to technology, human technology later, but if these 3 forces have allowed life to evolve on planet Earth over the last billions of years, as we did our research, we also found some of your work which says that Earth has already reached a resource constraint where it cannot sustain human life any longer. But wouldn't we be able to really evolve and continue to live life on Earth, and sustainability should not be an issue given endosymbionts, given energetics, and given biological innovation?
That's an excellent question. So I would kind of modify that a little bit. My argument would be not so much that we've reached the point where the Earth can't sustain human life, but we because humans in with a smaller population size and a different kinds of societies could certainly continue to exist on the Earth for a long time. But the question is whether the Earth can currently, how well it can sustain the current rate of growth in consumption and population size that we see today. And I think that's an open question. But yes, in a few papers, I've argued with collaborators that it just seems like we're really approaching these limits, and others have argued this too. We can kind of break down the constraints into, there's an energetic constraint, which many are familiar with. So currently we really rely on fossil fuels.
Yeah.
And those are running out. And they also damage the planet by increasing carbon dioxide in the atmosphere. So we need to transition away from that to avoid that constraint. And so that requires an innovation in our energy systems, which we are, as societies are working on, switching to alternative energies. But it's that can kind of push the constraints of energetics if we can accomplish that. Now, it's not clear necessarily how easily we can do that. So it'll be challenging. I'm not saying we can't, but it will be challenging because we really have to scale up all these other energy systems, and they also use a lot of resources to produce. A lot of mineral resources. We have to get those minerals. That requires energy to dig them up, to process them. They have to be transported across the globe. So there's a lot of changes that have to occur that all requires a lot of energy and a lot of organization and informational complexity of sorting out those details. So even if we do that, if our population continues to grow really quickly, we're still going to be then pushing up against energy limits. So at the same time, we have to figure out ways of regulating our population size. And we have to also, it's hard to know, but it may not come down, some of the most difficult constraints that the global society will face may not end up being energy. It could be other kinds of resources that are already in short supply. Such as phosphorus for fertilization and agricultural systems, or just a good healthy soils, water. There's lots of rare earth elements and other minerals that are very hard to find substitutes for in our current technologies. So in some cases they don't have substitutes. In other cases they do, but those substitutes are more expensive to dig up. And don't work as well. So as our technologies become more complex, they'll require more energy to develop these technologies and to move things around the globe.
So your argument for challenge to sustainability of life on planet Earth is primarily revolving around the energy constraints. So when we talk about endosymbionts, energy, and biological evolution, you're talking energy as the primary constraint. And then you have also another paper which talks about this Malthusian Darwinian dynamic, right? And so the argument that you're making right now seems to be focused on the theory that the Malthusian dynamic will drive our future on Earth, while Darwin says adaptation drives. So what is to say that in the future, we as human beings won't evolve into something that will allow us to, still survive with whatever resources we have? I mean, apes never thought they will become humans, right? And the fish never thought it'll become a bird. So why do we have the hubris to think that we will remain as humans as we are and we can really control the environment? Why don't we just let it be and become whatever we become in the future?
Yes, excellent question. So another way of thinking of the MDD is the Malthusian Darwinian dynamic the term we sort of coined is that is there's this problem cycle in all populations, including human populations, where they might adapt to some constraints, some limits, but then when they do that, when they lift that limit, then there's a population growth, and then they reach that limit again. So there's in humans, there could be, they come up with some technology to deal with some environmental problem, you could call it an environmental problem, say, but then that leads to a whole nother problem. And so there's kind of this cycle. So there's no, as Darwin pointed out, there is this populations will try and adapt to difficulties, as in that's just the part of natural selection, but there's no guarantee that they adapt in time before some environmental problem or some social problem within the population, or whatever leads to a collapse in that population. So there's no guarantee, there's no law saying that populations are necessarily going to innovate before they collapse. And in fact, there's lots of examples where populations don't, both in humans and other organisms. So as I think you've kind of alluded to, is I do think, though, that I don't see a reason to think that humans would just go extinct. We're so flexible and resilient, but there is this possibility that at some point, say in 10, 20,000 years, that we would have sort of, our society would actually simplify again because of constraints on resources and geopolitical instability. And so there's no guarantee that we can all maintain the complexity that we've created today, but there is the possibility that we can continue to increase it, including, through something like space exploration and colonization.
No, you brought up a very, very good point. I mean, the point of distinction that you brought in was it's a race against time, and it's a race of whether you will become extinct before you evolve from a natural selection timeline. And so that basically says that you are trying to not become extinct before you can evolve, which means you're going to use technology innovations to avoid extinction, and that would include space travel. So is that a fair way of really paraphrasing what you just said? That's the race that you are fighting?
Yes, I think so. Yeah, and I would add to that that we talk a lot about innovation in humans, and we think about it often as it relating to technology, which is certainly one good example of innovation. But some of these challenges may also be addressed with innovations and more like the social or political or economic structure. And in a way, those actually some of those can be considered technologies. There's a lot of things that we don't necessarily, as a layperson, we don't think about as being technologies, but they are in a sense technologies, like medicine, drugs, including, herbs that people have been taking, traditional people have been taking for a long time, that affect their bodies and affect their activities. They might make it, like a stimulant might make it so they can work harder in the fields to extract more food and more energy from the fields. So technology has played a huge role in human evolution for a long time, and today it's a driver of the future of society. It's interacting with capitalism. The two kind of go hand in hand. I think these are the things that are really shaping a lot of the directions that I think, that this is my view on it, that the directions that human society are taking are through this technological evolution. And it's easy to think that we have more control over the technological evolution, but it and capitalism are really driving a lot of trajectories. And so I think a big part of the future is going to be figuring out how can we regulate more that technological evolution, regulate more the way capitalism is operating, so that we can choose the future that we want for humans at a global scale.
And that's a big complex problem, right?
Getting
to what is the common future that we want, getting 7 billion people to agree on that in itself is a challenge.
Yeah.
When within the country we can't. But so you started to talk about the human body, and you started to talk about external technology, including health technology. But as a biologist who is also interested in evolution, are you seeing human bodies themselves changing? Have we evolved in our capacity at all over last millions of years since we have been on planet Earth, which has given us different, do you see any signals at all in your research around the evolution of the human body itself over last years and the trajectory going forward?
Well, I'm not an expert on human biology evolution, but as I understand it, in the past, evolutionary biologists and geneticists thought that the rate of biological evolution was slow, so slow that probably, let's say over the course of hundreds or 1,000 years in humans, there wasn't really the opportunity for much change, for much human evolution in our bodies. But a lot of that, I think those assumptions have been a little bit questioned. So there have been some more documented cases of human evolution, and we can kind of see that in the sense that if we compare different populations across the globe, there are sometimes differences in some of the frequencies of different alleles, or so that's like the way the genes are, and which have repercussions for the health of those humans in those places. So certainly, yes, there has been human evolution, and it'll continue. Humans will continue to evolve in different ways. There's also, at a faster pace, can be faster evolution in terms of the microbiome within our guts and on our skin, because those organisms reproduce very quickly. They can change quickly, and also it's like we harbor a community of organisms in our guts. So that's more like ecology at work in terms of which species are present and which are absent. And there's no question that modern life has affected the composition of that gut microbiome based on our lifestyle, on the food we eat, like for example, how much fiber we get, how much various other plant metabolites we consume, and just all the alterations in our diet are having a huge impact on our gut microbiome, which affects the operation of the rest of the body, including the brain and the immune system, because the gut microbiome is right there against in the intestines, where the immune system is very active, and so the two are tightly talking to each other, and that even can affect things. It's thought to affect things possibly such as the development of autism, possibly other kinds of metabolic disorders or chronic inflammation. So yes, there's a lot of things that are changing with the human body, not necessarily all in terms of our genetics, but in terms of the way our body is functioning. It's changing in the modern lifestyle. And one last thing is also, of course, all the toxins, environmental or industrial chemicals, household chemicals that get released into the environment they get into our bodies and as well as into other animals, and that there's been plenty of documentation of that affecting things like hormone levels in certain cases. So that affects possibly even human behavior.
No, that's a very good breakdown. From genetic perspective, from a microbiome perspective, and then impact of toxins. And frankly, I have no evidence for this. It's just my theory, but I moved from India to the US when I was 25 years old. In India, growing up, I used to have a lot of infections. Coming to the US, all the infections went away, but now I have seasonal allergies. So it has to be the microbiome in my gut that has changed it. So, but this is something a lot of people have noticed, that when they change their environment, when they move from one location to another, the diseases that they tended to have go away and new diseases start to happen. So it may be microbiome, it could be, whatever else. I don't have evidence, but just my mind went there as you talked about the microbiome. So basically, if I just think back to what we have talked about so far, what we have said is evolution continues to happen. Human evolution is happening, but maybe not at as fast a pace as may be required to outrun the sustainability crisis. And then, so if we agree with that, now let's switch gears and talk about role of technology in space. So is the race for space then really a way to find new environments, or is it curiosity at this time?
Yeah, it's a huge topic. The role for space currently is, a lot of it is curiosity. It's scientifically driven. But there's a lot of investments in it in the space industry, in terms of trying to figure out the degree to which energy or mineral resources will be useful as being extracted from space. Of course, we already use space a lot for our satellite technology, for our information technology.
Yeah.
But today we don't have that. I don't think that space is going to play a major role in addressing our sustainability issues over the next 100 years or something like that. If trying to put a number to it, the reason is it's just very difficult to make it viable to get substantial minerals and bring them back to Earth. And even if we do, it's not going to address the bottom line of in terms of the need for resources or energy on Earth. It maybe energy technologies could help on Earth in the form of solar energy in space, but I don't see that in terms of resources. In terms of colonizing other environments, it's almost part of our DNA to explore and colonize. It'll help us expand through the universe. Maybe we can set up a few colonies here and there, but unless we can get all the way to a planet that is as habitable as something like Earth, it's not going to have an impact on kind of the likelihood that something bad happens to humans as a species, because I don't think it'll have a huge impact. There's the idea of terraforming a planet such as Mars, but that would take a long time and a lot of energy. So it's not something we can do in time before we deal with all these issues on Earth. So I don't think it's sort of the solution per se, but I don't think it's a bad thing to go into space at all. And I think it's really fascinating to learn more about space and where life might reside, and try and explore these options of extracting resources. But as an ecologist, I do wish that maybe more resources, more attention were put towards instead addressing human environment interactions on Earth, and also how to address human behavior and sustainability on Earth. So I think we can't ignore those things either. So we no matter what, we're going to have to take a multifaceted approach, using a lot of different approaches, a lot of different strategies and tactics. Like you said, that any sort of global scale agreements or level of organization at the global scale is very difficult. But at some level, it will be required. We'll have to figure out ways of minimizing conflict and increasing cooperation between nations, so that we can regulate our metabolism as a planet.
No, fair that space might remain more in the space of romanticism for next 100 years than an actual solution. But on the other side, you talked about finding habitable planets, and
Yeah.
all the literature that I'm reading right now says that we have now increased our supercomputing power so many folds that by 2025 we will find Earth-like planet that we
Yeah.
can go to. I think there was a couple of weeks ago news about an exoplanet that has a lot of water.
Uh,
So let us assume, we find one.
yeah.
You also talked about that in the school that you are at, you are doing studies about, other planets and biology of other planets. So talk to us a little bit more about that. What are you focusing on? How do you really approach doing that research, and
Yeah.
why do you do it, and what do you find, and what are you finding in there right now?
Sure. Yeah. So first, but I'll start with your first point and then go on to what I'm researching and my interest there is. Yeah, I agree. I think it's really fascinating to think about how, in terms of really, large time scales, where humans may end up in the universe
Yeah.
in thousands of years. And this idea that if there are habitable planets that aren't too far away that we can send people to, that there is this possibility of humans expanding and more in our galaxy, so that it won't affect the bottom line of sustainability on Earth, but it could lead to these other colonies that could have very thriving societies for a long time, and hopefully that maybe they'll figure out better how to deal with their planets and how to regulate their planet, or at some point maybe the Earth will figure it out. So I really do like thinking about that, and a fan of science fiction as a kid. I always enjoyed imagining kind of where humans would end up being. So that brings me to my research on these topics. So a lot of my interest is asking, okay, what would we expect life to look like on other planets, habitable planets, based on the characteristics of that planet, so its environmental conditions, how long its history, how long the planet has been around for, and a first step in addressing that, it's a very difficult question,
I'm sure,
because we only have life on Earth. That's all we've studied so far. So I start with life on Earth and ask, okay, what laws of biology that we've developed in studying life on Earth seem to be universal, as in they seem to not depend on the details of the biochemistry of Earth, but rather they're just dependent on basic laws of physics and chemistry or geometry. And then ask, okay, so once we identify these laws, can we use them to predict, what life might look like on some other planet? So do we think life is going to be just tiny microbes on the planet, or is there the possibility that larger organisms will have evolved, and would those organisms be able to move around, or fly, or swim, or just or be attached to surfaces? Will they be more complex organisms that maybe have gone through several transitions in individuality? That's a term for the endosymbiosis, where the organism actually has organisms living within it that have become so dependent on the host organism that they're integrated into this individual. So humans are an example of that. We have these mitochondria in our cells, we're endosymbionts. They used to be free living organisms. Now we rely on them. So will the organisms be like that, or they just be these simple bacteria or some other structure? And there's a lot of laws we can start to use to kind of make predictions, to get some idea at least of expectations. So for example, over the course of Earth history, there's a clear increase in the maximum body size of organisms, going from tiny little cells, and they kind of increase in these step functions each time there's an innovation. So they start out with prokaryotes, so those are like bacteria and archaea, and then there is a an innovation of endosymbiosis that lead to a huge increase in maximum size of organisms. And then the innovation in multicellularity of those eukaryotes that led to the multicellular eukaryotes, so plants and animals and some fungi. And then another innovation was sociality, so like eusociality, which is like where these multicellular organisms, some of them became so social within a species that they formed these social colonies.
Yeah.
They're very tightly integrated and dependent on each other. That some biologists call superorganisms.
Yeah. Yeah.
Humans could fall into that. Yeah.
Mm-hmm.
So, but that all took a lot of time. It took millions and millions of years. So then we can, if we find a planet that just formed recently and it has similar conditions as Earth, then probably they're just based on the rate of evolution of kinetics. Kinetics is like this, in this case, the speed of chemical reactions, which affects rates of evolution. We would not expect the large organisms to have had time to evolve.
Right.
Another constraint would be the amount of resources available. If there's just too little resources, then there may not be enough resources to support a large-bodied organism. And there are scaling laws that predict the size of an organism based on the amount of resources available in those habitats. And so those can be applied to making predictions on other planets.
So why do we do that? Yeah. Why do we study this? Are we trying to use this to predict which planets we should focus on? Why do we do this?
Well, that's an excellent question. Yeah. So for me, there's two motivations. So one is, I think it's an excellent way to really interrogate our understanding of biology on Earth. To ask this question, to what degree does our understanding of biology apply to life elsewhere, and where are there big missing holes in our understanding? So it's sort of that's one reason. Another is purely intellectual. I think a lot of astrobiologists, it's sort of an intellectual fascination with thinking about life elsewhere in the universe. For me, that is a motivation as well. It's not the core of my research, because I prefer to really kind of focus on life on Earth overall. But I think it is a part of my motivation. And the third thing is it's a great way of getting students interested and involved in biology and astrobiology. So like I'll be teaching a class that's on astrobiology that will do kind of as I described. We're going to explore the degree, kind of what life might look like, especially complex life on other planets, by understanding the laws of life on Earth.
Wow.
So it's a way of getting people that maybe aren't biologists to learn some of the really fascinating theory in biology that I think a lot of people, when they get exposed to biology, it's more at first like seems very fact oriented. It's a lot of memorization. And this is a way of getting away from that approach to teaching biology to one that's more just to try and get people's imagination and interests in biology.
Yeah. So does NASA support a lot of this research? Or, what is the government really, NSF, others supporting this?
Yeah, NASA supports a fair amount of research in astrobiology. They have programs that are dedicated to funding research on understanding the early evolution of life, laws of life, evolution of biocomplexity, of social organisms. So they're very much interested in some of these questions. NSF does as well, but they don't fund astrobiology per se, I would say. So usually you just have to coin the research in a different way.
Got it. So let me come back to one of the original questions that we had, and I think you have just made the case for it.
Yeah.
Basically, what you said is our race is against time in terms of whether we will become extinct before we evolve.
Yeah.
So going back to the role of health technology. So I mean, that seems to be, I mean, we can talk of information technology, but it looks like health technology will be the enabler of avoiding extinction. So would you agree with that thesis that will be the next wave of innovation that we will see, or would you disagree?
Oh, yeah, that's a big question. I was really fascinated to learn about this question and thesis that you're exploring, because that's not something that had really occurred to me, to think about healthcare technology as having such a prominent role in a sort of a next wave of an industrial revolution. I guess my first reaction was, I don't know, I don't see it that way. But then I thought, well, if we think big picture, like about space exploration, space colonization, yes, that certainly it seems like in order for humans to live in really different environments, especially planetary bodies that have different gravity, we're going to need to use all sorts of technologies, including healthcare technology, to help deal with some of the health issues that arise from those different environments. So for that really big picture possible future of humans, it seems like it would play a vital role. Also, I mean, I certainly think it can play a role in like helping humans learn how to increase their health spans and across all levels of society. Mm-hmm. So I think sort of the healthcare technology goes hand in hand with also addressing other lifestyle issues, as well as food production issues and production and transportation issues. So there's plenty of people that aren't getting enough food, enough nutrients at a global scale. So the healthcare technology isn't going to help with that too much, because it's more a question of food. But there's also, it can play a huge role in helping people live longer and in a healthy, happy way, active way. So as the demographics age, if we try and lower population growth, we're going to have aging demographics. So healthcare technology will play more and more of a role. And I think some of it is going to be, that's where there's a lot of need for advancement, isn't just in the use of pharmaceutical drugs, but in figuring out ways of helping people regulate their lifestyle so that they live healthier. And that can really have a huge impact on reducing rates of obesity, chronic inflammation, depression. So figuring out how to deal with some of the stress of modern lifestyle, and also the bombardments in modern lifestyle of all this food that can fuel a lot of disease. So the healthcare technology can play a role in helping with that, I think, very much so. Yeah.
So, I mean, you talked about the use of healthcare technology, yes, in adapting to space, but on planet Earth, you talked about it mostly, the application mostly in terms of maintaining what our view of normal is, right? Normal human being. But let's say there's an energy constraint, there is food constraint, and the wet temperature is so high that human body can't survive. So would it be out of the realm of possibility that we use health technology to adapt human body on planet Earth to be able to, say, survive in very high wet temperature areas, or human body to survive on less food, or human body to survive without the need for energy used in cooling and heating our buildings? So do you see a future where that is a realm of possibility, or is that just too science fiction?
No, I don't think it's too science fiction. I think it's a really intriguing and sort of a creative idea. to try and to think of ways of making healthcare technology help in dealing with like sustainability challenges. I don't think many people are thinking that way, but and that goes back to kind of my point about figuring out how to regulate capitalism. So if when as governments, if they can encourage healthcare technologies to go in that direction of helping with sustainability issues, that could be really useful. And certainly, people in most developed countries could probably eat less and they would be healthier. So, yes. But there's this, it's very hard to eat less when there is this food industry that is designing their products to make you want to eat them as much as possible. So that's, goes back to my point about this technology. The food industry is building technologies like chips or something that are so delightfully crunchy and salty and, and they have that right feeling on your tongue that you just want to keep on eating it.
Exactly.
So we have to, those things are intertwined. And I think that's really fascinating to think of how we can do that.
Yeah, no, you bring up the good, the boon and bane of human race, right? Ultimately, it is capitalism, economic development that tends to drive a lot of innovation. And we'll see, where it goes. Maybe there'll be a point where it makes economic sense to use health technology to actually modify human bodies versus use resources more efficiently. We haven't reached that balance yet, but maybe we will one day. Very interesting discussion. Yeah, go ahead.
I just want to add, because you bring that up, and I think there are some inklings of what maybe you would call healthcare technology, in the sense of people interested in trying to improve their health through technologies like what's it called, like Fitbit watches, or apps, on their phones that encourage them to get X number of steps per day or something like that. So those are interesting emerging ways that healthcare technology may be playing a role.
And there is certainly quite a bit of a push on prevention through technology rather than getting into a phase where you need treatment. And then we'll have to see if we ever get to a point where you are not only using technology to prevent, but using technology to modify so it never happens in the first place. There'll be a big shift. I don't think we are there yet. I don't think the capitalistic structures and economic structures and societal structures and regulatory structures and ethical structures allow for that today. But I'm also not opposed to the idea that at one point in time, it's always about balance, right? The cost of modifying humans may actually be lower than cost of finding resources. And then that is where, the shift might happen. So we will see.
Oh, interesting.
We are not there yet, for sure. But Anthony Tillman, I know you have been listening keenly. Any questions you have for Jordan?
Yeah, so Dr. Okie, first and foremost, thank you for taking the time to make an appearance on the show. I think I can speak for everyone when I say it's really insightful discussion. We covered a whole lot of talking points. But one of the things that I wanted to do was, in pre-production, sort of the point that I kept bringing home was, hey, Dr. Okie has a lot to say about sustainability, and a lot of the articles that we had actually pulled from your work were from maybe 8, 9, or 10 years ago, or maybe even a little bit sooner than that. But one thing I was interested in kind of hearing your opinion on is, I remember as a kid growing up, I would always see a lot of PSAs and commercials saying save the earth and whatnot, or along the lines of that. And now I feel like today in the 21st century, we've kind of transitioned from we've transitioned from combating global warming to kind of living with it and finding ways around it, for example, artificial ecosystems. And I was just wondering what your thoughts on that. Do you think that's true? Do you think that's beneficial, or do you think there's a certain way we should attack that?
Great question. So I think it makes sense to take multiple approaches. So we certainly, where we create artificial environments, built environments for ourselves. That's been part of human history for a long time. So it makes sense that we're going to continue to refine our approach to our built environment so that we can live more comfortably and using less resources in those environments. you mentioned about, this idea of, okay, save the earth. I think in a way that, that maybe is not the best way that environmentalists have tried to get people interested in protecting the environment or changing their habits, because the fact of the matter is humans have been altering their environment for a long, long time, even before, the Industrial Revolution. All over the planet. We have modified ecosystems. So there's very few places that you can really consider to be wild. So it's more about what kind of future planet do we want? What do we want those ecosystems to look like? And is there ethics that we want to take into consideration? And ethics is a complex topic, but one person might have the ethics that it's wrong to harm and kill off a lot of species. So right now we're dealing with an extinction crisis that's human caused, and so that would be one ethical dilemma is trying to reduce the extinction of species. So we have to think about, okay, how are we going to modify our planet so that we can reduce the loss of biodiversity? We can have ecosystems that provide ecosystem services to humans, which includes food. So that requires water and healthy soils. And also ecosystems that we enjoy being around. There's a lot of studies showing how helpful being in nature or out in the environment, the outdoors, is to mental and physical health. So we may want to have a planet that isn't completely paved over, but rather that where we keep some land with lots of different plants and animals, and we have agricultural systems maybe that aren't just monocultures across huge fields, but that integrate agricultural plants and wild plants. So that's kind of I think part of the question is what kind of future do we want and how do we get there? But certainly it's not just about saving the planet. It's about making the planet in a way that we like and that fits within some ethics that we develop as society, because we do have various kinds of ethics. So we have to think about what those are and how we want to use those or how those should guide the way we modify the planet in the future.
Yeah, no, the topic of ethics is definitely an interesting one. And I just want to do a quick follow-up with you, if you don't mind on that.
Yeah.
Do you foresee a future in which we're sort of artificially engineering climates, like, for example, a heat wave? Do you foresee a future in which we are sort of artificially engineering so that heat wave is not sort of the case? Or do you foresee carbon emission levels miraculously dropping in the future? I just want to know what your takeaway is on that.
Okay, yeah, that's a great question. So, because I have my own opinion, and then there's what you say, what I foresee. I think based on past human history, I foresee that it'll be very hard not to be tempted to do what you're talking about, to try and modify the climate through technological means, whether it's putting stuff in the oceans to affect the albedo, the reflectivity of the oceans or something, or putting stuff in the atmosphere for the affect reflectivity in the atmosphere, or like you say, somehow trying to affect more at a regional scale, the cooling or warming in a region. It's going to be very hard not to be tempted to do that, because when we have technology and tools, we're also tempted to use them, even though sometimes a technology innovation isn't a good thing. And there are lots of cases of biological control where we introduce species or even genes into an environment to try and alter some species, to try and keep it from propagating or something, or to modify that ecosystem. And many of those cases go badly. They don't end up working out, but we still do them. We continue to do. Like in Florida, to try and reduce some insect populations. Right. They did something, I can't remember. Yeah, and so there's lots of examples that goes badly. So my own personal take as well, often it goes badly. And I don't think the risk is worth the reward, especially because it doesn't address the fundamental issues of our human population. It's just like kind of delaying things a little bit, but it might create a whole other set of problems. The atmosphere, the climate system is so complex. There's a lot of possibilities for nonlinearities and unpredictable behavior in the climates that could really backfire on us.
Thank you.
No, I mean, I think one word that you just used, Jordan, non-linearity, is a very, very important one. We tend to think of our world, life, evolution, innovation, technology, everything in a linear fashion, but nothing happens in a linear fashion. And if we can really wrap our head around that, maybe we will figure out a different way of solving for these topics. But there's a fine line between, thinking linearly and non-linearly, and we have to train our mind to think non-linearly to solve these problems.
Yes, yeah, and it's very difficult. The mind
very
isn't trained, or it's not.
We are not trained. Yeah, we always are trained to go A to B to C, and if it is X, then it is Y. That's how critical thinking works. But maybe we need not critical thinking, but non-linear thinking to solve for these problems. So yeah, Tillman, anything from your perspective?
So I'd like to pair what Anthony said. So thank you very much for coming on. I thought this was a great discussion. The one thing I wanted to ask, I kind of wanted to go back to biological adaptation. So are you familiar with the Russian boars in Texas? That whole situation?
No.
Okay. So you'll love this. And this is something I think that you should look into this after. So in the 30s, 40s, 50s, when we cared less about the effect of things, people brought over Russian boars into Texas to hunt them for sport. And of course, if you don't get every single one and they get out into the wilderness, whatever, they'll propagate. And so now there's a huge infestation of Russian boars in Texas. Now the population's exploded to the point where there's a year-round open season on them. Please get rid of them. That's what they're asking for. But what the most interesting thing about the situation is to me is that if a domesticated pig, one of our favorite, bacon, pink, cute, hairless pigs, gets out and escapes domestication, they will join a Russian boar pig clan. And this is the same pig, over weeks and months, they'll start developing a mane, they'll start growing tusks. This is not over generations. This is weeks within propagating. And it's not because they're going through some crazy evolution in a few weeks. It's that they're unlocking genes that were repressed through domestication. So I guess my question is, do you see a parallel perhaps in human beings? Are we becoming domesticated to the point that we're repressing certain aspects of our genetic code, or am I just completely off base and there's no similarity and this is just a weird one-off Russian boar situation?
No, I think that's a great question, because that is something I'm concerned about. I'm not an expert, but I'm well aware of some of the work that some colleagues in ecotoxicology have done, where they've shown how toxins that we're producing as a fossil fuel driven society, all these plastic derivatives, they end up in our environments, and then they end up in us, in our foods, and we just get them all, we just get them in the dust that we're breathing in. And some of these, they do affect the regulation of hormones. So some of them may act like estrogen, for example, or have other effects on our hormones, or the receptors that the hormones are reacting with. And that may be affecting our behavior and health in subtle ways that we're only starting to realize. It may be, leading to people, having more issues with possibly, like in men, maybe low testosterone or something like that, which can lead to health issues or physical or mental. There have been studies, showing when these sorts of toxins do affect fertility in men or women, or may affect development of both the fetus or a baby. So it's certainly, yeah, there's possibly changes in what genes are being regulated. So because hormones affect what genes get expressed and which don't. And that kind of concerns me, because it could lead to this downward spiral or something. That's like, the more toxins we put in the environment, the more it affects our behavior in some negative way. It could lead to people having more trouble being healthy or being working members of society, and that could affect certainly the future of humans.
Yeah, and I mean, I don't know if any of you have done 23andMe. I did my 23andMe test, a couple of years ago, and now every other week I get an email with an update. Either I found more relatives or whatever. But one interesting thing I found through my 23andMe is, I always felt that mosquitoes bite me more than they bite other people. And 23andMe actually confirmed that is the case with me, because I am not more Neanderthal than 90+% of human population. So there is a Neanderthal gene in me still, which makes which makes me feel mosquito bites more than,
Oh, fascinating.
the rest of the people. So, I mean, there is certainly, something to do with this genetic evolution and how our bodies are adapting. And I mean, it again brings me back to the framework that you provided, which is the framework around race against time versus anything else. Will we evolve? I mean, mosquito is a fun example, but if you amplify it into other serious conditions, it can be really seen as a race against time. So thank you so much, Jordan, for your time. This was very, very, very insightful. It's always good to get views from different perspectives, and your view was very, very informative. Anything else that you would like to say before we end this?
Well, I don't think so. I think, I really enjoyed our discussion, and I appreciated all the questions you all had. It's such a fascinating, complex topic. I think it's really great what you guys are doing, because I think one of the most important things moving forward is having this involved discourse. It's going to necessarily involve a lot of disagreements.
Yes.
But we have to argue about it. We have to try and think through all the possibilities, the ideas, and it really seems like that's what you're doing. You're really wrestling with these big picture questions in human society and evolution. So I very much appreciate it.
Thank you so much. Thank you for that compliment. Yes, it is certainly a hypothesis, and we are gathering multiple perspectives. But what I will tell you is, I mean, we are only a few weeks into our discussions, but at least in my mind, Anthony Tillman, you tell me, but a picture is beginning to emerge where we see a lot more convergence than divergence.
So that's great.
So that's a good
glad
thing.
to hear. I look forward to seeing how it all evolves. Yeah, that's cool.
Yeah, so of course we will keep in touch. We will email you this video so you have it for your records as well. But again, thank you so much for your time this
You're
morning.
welcome.
Your time.
Yeah.
Really enjoyed it.
You're welcome. Thank you.
Thank you. Well, that was a great conversation with Dr. Jordan Okie. Really thanks to him. We have a new perspective today on the topic we are grappling with. For me, the two key takeaways. One is the race we are in as humans is not a race for space, but it's a race to avoid extinction. According to him, we may not have enough time where our bodies could evolve from a Darwinian perspective to adapt to the changing nature of planet Earth. And to avoid extinction, we may take on different initiatives, whether to make life more sustainable on Earth or to go out into space, even though he thinks space is a little bit more far-fetched than Earth. But it is a race against time to avoid extinction and not waiting for evolution to happen. The second key takeaway for me is this whole idea of non-linear thinking. Evolution has not happened in a linear fashion. Thinking doesn't happen in a linear fashion. However, the traditional problem solving tool sets that we have are all linearly designed, where you have a problem, you have a solution, you have a problem, you have a solution, you do scenario planning, et cetera, and you think linearly. But the topics that we are really grappling with, and then the topics we will have to come to terms with as we move forward, will be solved by non-linear thinking, not linear critical thinking that we all have been advocates for. Now, how do we do that? I don't know. But another topic that we have to really think about more in the future. How can we think non-linearly to solve for these very complex problems? With that, thank you so much for listening. It was a great pleasure. We continue to learn, and hopefully you do too. You take care. See you again. Bye-bye.